Hello dear viewers, today we will discuss about force, mass and acceleration. Here are some points that we will discuss with you. We represent the force that the motors on a train provide to cause it to accelerate. You know that there is actually a train which is shown in the figure. There is actually representing a force. That is the force, a resultant force. The second point shows the resultant force is represented by the green arrow. You know that there is green arrow. This is the green arrow which shows that force is how much? That is a resultant force. That is 20,000. This is 20,000 Newton. Next point is the direction of the arrow shows the direction of the resultant force. Clearly it shows that this is the direction of the arrow. So it is towards left side. It is direction which shows that where is the force applied. Next point is the magnitude. That means the size of the resultant force of 20,000 is also shown. You know that there is actually the magnitude. That means this is the magnitude size of the force. How much is actually the force which is applied on this train? That is 20,000 Newton. And in B part there is also the train which is representing, but it is the second part when the train is at the station. That means when it stops. So we will discuss here an example to calculate the acceleration A of the train produced by resultant force F. Here is a resultant force F and acceleration is A. We must also know that train's mass is M. Mass is M. So here is important point that we will discuss with you, that is F is equal to ma. It is the famous relation, that is Newton's second law. This is actually the relation between force, mass and acceleration. You can easily find out the acceleration. How? That is A equal to F divided by M. You know that what is actually the force which is applied on this train to the left direction, that is 20,000. So it is 20,000. Very easy. It is 20,000 divided by M. M is actually the mass. What is the mass of the train? Mass of the train is 10,000. So it is 10,000. Now you know that 4 zeros in the numerator and 4 zeros in the denominator. So we will cancel both. So it will come out 2 meter per second square. Why we take meter per second square? Because it is actually the acceleration. It is actually the acceleration. Acceleration is having the unit, that is meter per second square. And in next case, the train is deaccelerating as it comes to the station. You know that now the train is coming into a station. Its acceleration is given, that is -3. Why we are writing here minus? Because it is deacceleration. It is deacceleration. Now the train stops. It comes to rest. After some time, it comes to rest. So what force must be provided by the braking system of the train? You know the braking system. What is the actual force which is applied due to which the train stops? So we will find it with the help of F is equal to ma. And now we will find force. So what is M? M is actually the mass of the train. And acceleration, that is negative, that is -3, that is the acceleration. So it will come out minus 30,000 Newton. This is actually the force which is applied on this train in opposite direction, due to which it stops. The minus sign shows that the force must act towards the right. Just to see this figure. In first case, the train is moving in this direction towards left, but in the second case, force is applied in opposite direction. When the force is applied in the opposite direction, definitely the train will stop. Whenever there is actually the force which is applied, suppose for example, if this is an object, suppose we are applying the force in the forward direction, in this direction, or it stops when we apply the force in the reverse direction. I hope these things will clear you. We will meet in next video with some new topic. Thank you to all.